You might know how to solve equations, but how do you solve inequalities? In this video, we'll learn how to solve one-step inequalities. Let's begin by taking a look at an equation that we already know how to solve. To solve this, we need to get x by itself. Since we have x plus 3, we need to undo the addition by 3 by subtracting 3 from both sides. This gives us x plus 3 minus 3 equals 7 minus 3. On the left-hand side, the 3's cancel out, leaving us with only x. And on the right-hand side, 7 minus 3 equals 4. So, x equals 4. But what if this wasn't an equation, but an inequality? Let's try to solve this the same way. First, let's subtract 3 from both sides. This gives us x plus 3 minus 3 is greater than 7 minus 3. On the left-hand side, the 3's cancel out, leaving us only x. And on the right-hand side, 7 minus 3 is 4. So we have x is greater than 4. How do we know if this is correct? Well, let's pick a value for x that is greater than 4 and plug it into our original inequality to check. Let's try x equals 5. Plugging this into our original inequality gives us 5 plus 3 is greater than 7. Simplifying on the left-hand side, we get 8. 8 is greater than 7. This is a true statement. Looks like we solved our inequality correctly. In fact, solving inequalities works almost exactly like solving equations. We can use inverse operations to get the variable by itself on one side of the inequality, and that is our solution. Let's look at some examples. Our first inequality is n plus 5 is less than 8. On the left-hand side, we have n plus 5, so we have to undo the addition with subtraction. Let's subtract 5 from both sides. On the left side, the 5's cancel out, leaving us with only n, and on the right side, 8 minus 5 is 3. This gives us a solution n is less than 3. Our next example is 7 is greater than or equal to p minus 4. On the right-hand side, we have p minus 4, so let's undo the subtraction with addition. Let's add 4 to both sides. On the left side, 7 plus 4 is 11, and on the right side, the 4's cancel out, leaving us with only p. This gives us the solution 11 is greater than or equal to p. We could also write p is less than or equal to 11, since that is the same thing. Our next example, we have t divided by 3 is greater than 7. On the left side, we have t divided by 3, so let's undo the division with multiplication. Let's multiply both sides by 3. On the left side, the 3's cancel out and leave us only t. On the right side, 7 times 3 is 21. This gives us the solution t is greater than 21. Okay, so far we've seen that solving inequalities is similar to solving equations. However, there is one exception. When we multiply or divide by a negative number, we must reverse the inequality sign. Let's look at two examples to apply this rule. The first is negative 3b is greater than or equal to negative 15. On the left side, we have b multiplied by negative 3. Let's undo the multiplication with division. Let's divide both sides by negative 3. And since we are dividing by a negative number, we must reverse the sign of the inequality. Now on the left side, the negative 3's will cancel out, leaving us with only b, and on the right side, negative 15 divided by negative 3 gives us positive 5. Our solution will be b is less than or equal to 5. Let's confirm that this is correct by plugging in a value for b. Let's choose a number for b that satisfies b is less than or equal to 5, say 4. Now we'll plug this into our original inequality to make sure that we get something true. Substituting 4 for b, we get negative 3 times 4 is greater than or equal to negative 15. Negative 3 times 4 is negative 12. So we have negative 12 is greater than or equal to negative 15. This is true, so reversing the inequality sign does work out. Our last example is r divided by negative 2 is less than or equal to 5. Since we have r divided by negative 2, let's multiply both sides by negative 2. And since we are multiplying by a negative number, we must reverse the sign of the inequality. On the left side, the negative 2's cancel out, leaving only r. And on the right side, 5 times negative 2 is negative 10. Our solution will be r is greater than or equal to negative 10. So we've seen that when solving inequalities, we can use the same rules as when solving equations, except when we multiply or divide by a negative number, we must reverse the inequality sign. Now you're ready to try some on your own.